All right, so you have your data now. The problem is data is often very messy. There are missing values in your data, or the variables don't have values that are ready for you to use in a regression yet. We need to create new variables perhaps, or there's just weird codings. So this coding system doesn't really allow us to look at the data and understand what's happening if we try to summarize anything. There's all kinds of things that we might want to do with our data before we ever start making any tables, running any regressions, making any graphs. There's all kinds of things that will make our life easier and help our results have some more meaning. So I'm going to show you some basic ideas to get started on data cleaning. Okay, so here I have already downloaded a file from IPMS USA, the American Community Survey, but what I'm going to go through here will work for any data that you may have, no matter the source. A lot of the methods I'm going to use will translate to any kind of data, but this is the one I'm working with, the CSV file here. So I'm going to start with, there's one thing we already know, which is we want to make sure we load the tidyverse here, and then once we bring in the data for the first time as a CSV file, the only thing I'm going to do first is make sure that all of the variable names are all in lowercase. R's coding system is case sensitive, so I don't want to ever hit shift really. It's only likely to lead to data errors. Okay, so now I brought in my raw data. This is straight from the website. I'm going to call it raw. I've got 3.3 million rows in my data and 27 variables. Okay. Next, we're going to have to type these variable names a lot. So if you look at your data, okay, like mine are actually pretty reasonable. Yours might be insane. So, for example, I'm going to use this DEG field variable quite often. It means what degree or what did this person major in college? Degree field. But maybe I don't want to type it that way. Maybe I want to rename it. So what I'm going to start doing is cleaning my data, okay? So I'm going to leave this raw one alone and just say I want to create a new data frame called clean, where I start with raw, pipe to a new line, and the first thing I'm going to do is just start renaming things. Now, if you're not planning to pull more data from a website like IPMS or something again, if you just have your data and you're like, this is for sure the final version of this, it might be easier to just rename them in Excel in your CSV file or your Excel file, because you just type right over the variable names. But if you're going to keep pulling in new versions of this raw CSV, then you would have to keep renaming them every time. So coding might help in this case. Anyways, so if you want to code it to rename, I could take my variable. So let's take degree field. And the way rename works is that you say what you want to call the thing. So I want to call it degree. It's called degree field now. And then if I run this, now I can check my clean version and just make sure for a little sanity check, did that do what I wanted it to? And indeed, degree is now here instead of degree field. So step one, if you want to rename variables, rename is your friend. Okay. Done. Now you might make a note, so I'm going to pipe to something else soon, but you might note this is how you rename variables. That's fine. Okay. Next, you might have a bunch of variables in your data that you really don't want, like you don't see a use for them, and when you look at your data, you kind of just want them to not be there because they get in the way. Like, for example, my data are from 2022, but they're only from 2022. Every person who filled out this, it's all 2022. I don't need to see this. So what I could do is do select. And select works one of two ways. You could either tell R what you want to select. So if I put year here, let's look at what happens. Well, now I've got one variable. It's only year. So that's not what I wanted, but I could do it this way. I could say year, okay, but keep degree and then keep education. So depending on how many variables you have and what you want to do with it, it might be easier to just say select negative year, which means I don't want year. I want everything else. So if we run this, now I have everything except for year. So I can use this to get rid of variables like the detailed race variable. I don't want that one. Run it, check it, and there it goes. Now I just have race by itself, not race in detail. So you can do this to kind of clean it up, get rid of things you don't want if you have things you don't want. So step 2, select or unselect variables. Negative says I don't want this. Do the opposite of selecting this, basically. All right, step 2, done. Renaming variables, done. All right, now, so we've got this clean data, and you might wonder, like, do I have missing values or how many unique values? I want to know something about my variables just ballpark it. What are we working with here? There's this cool package and function called skim. So if you don't have this yet, probably you don't, you want to install skimr. I'll run it anyways, even though I have it. It'll update. Great. And then of course you need to load in the functions of the package. Library skimr. Okay, I usually like to leave all my library commands up here at the top. Then when I reopen my script file, I'll just come in here, highlight them all, load all my packages for this script, and we're good to go. All right, I'll see what it does. So skim is going to take an entire data frame and just give you a snapshot of what's happening in it. So if I do skim clean, it's saying, I don't know, you can call it like preview the data. And this will be necessary for data cleaning purposes because let's see what happens. So if I do skim clean, I have 3.3 million observations, so it might take 5 or 10 seconds. Okay, but skim function, there it is. Now here's what you can see when you do this, okay? Number 1, it's going to show you, well, the name of the data frame is clean, number of rows, number of columns. We already know all of that though. Okay. Then it's going to tell you what type of variables you have. Now these are different than the types that we talk about in class. These are types according to R, which are just like R saying, are they numbers or are they letters, basically, is what it's doing. But of course we know numeric variables can be categorical. So, but this is still necessary from a coding purpose because we know how R is going to treat these, okay? So what it's telling me is that I have all 25 of my variables are numeric, and no question, if I open clean, it's actually all numbers because this data repository that I'm using, everything is numeric, even if they're categorical, like occupation. It's a categorical variable, but it's numeric to R. So it just says, skim says, you've got 25 numeric variables, got no grouping variables, no character variables, nothing. Okay. But then it will also summarize them each for me, okay? So within the numeric ones at least, it will say a lot of different information. Number 1, my first column says how many are missing, how many are NA, missing, okay? Now, for you, this will be like a percent. It might be 0.17, which means 17% of observations are missing this value on this variable, like they're NA when you open it. Now, it just so happens that for my data source, missings get coded as zeros, and so R thinks that none are missing. So this is where you need to have some expertise about your data a little bit, right? Like, I have this variable called degree. What major did this degree holder? What is the major of their degree? There's a lot of zeros. There's a 23, right? And 0, well, let me show you how I would make sure of this. all data have some kind of a code book, some system behind which you can figure out what the codes mean. So within IPUMs, it would go something like this. The best way to do it is to say, like, revise my abstract, or somehow go back into the data extract, click on this thing you want to know, degree field. This reports the field in which the person received a bachelor's degree, if they hold one. So I click on codes. Now this tells me what all these codes mean. So that person, that 23, code 23, they have a degree in education administration or teaching. And it also says zeros mean NA. And I might wonder, NA, why NA? Well, Universe says only people who answered this are the people with a bachelor's degree, so if it says 0, that just means they don't have a bachelor's degree. So that's the reason. Okay. So I don't have any missings, but that's only a technicality for R. All the zeros are kind of missings. So, in fact, I never have any missings for any variables, but that's only because of this coding system that's used. Your data may have missings, in which case this one will show what percent are NAs. Okay. Complete rate is just the opposite. What fraction have data? So it's 1 minus n missing. You can also see quick versions of means, but of course some of these won't make any sense. What is the mean of my degrees? Well, zeros are, it doesn't make sense, but they'll calculate them anyways. 0th percentile, 25th, 50th, 75th, and 100th percentile, otherwise known as the max. So I can just glance quick. Age, the oldest person in my data is 97. The youngest has a 0. So again, this is where I can get little triggers like 0. I mean, like a newborn baby filled out a survey here. Maybe I need to do something with that in my data, right? Because maybe I don't think 0-year-olds should end up in my analysis. That's something we might consider later. Okay, but the skim can kind of give you a quick snapshot of what's happening here. Okay. Great. Now, let's say that I want to recode some of the variable types. So, for example, R thinks that education is a numeric variable, so it wants to take the mean of this stupid thing, okay? Which never makes sense. Degree, let's do degree. 11.8 as a average never makes sense. It's averaging across these stupid numbers. They're just codes. So if I wanted to recode a variable type, I'm going to keep going on this clean, because I just always kind of come back to this clean chunk here and just keep adding whenever I need to do something else. So all I would really need to do is, well, let's ask ChatGPT in R how to recode a variable from numeric to a grouping variable. See what it says. Cut grouping variables. Okay. I don't know. I don't think that's right. I don't think that's what I want to do. Let's try this. Mutate degree equals as, and this is where I can tell R what do I want to make it into. So right now it's numeric. So like there's one in here called as numeric. It's a function. It says take that variable and make it a numeric. We don't care what it is. Make it. It's really a number. So force it to be a number. Okay. Factor is R's version of category. See, so it says the function factor encodes a vector, which is just a variable, to be a category. Okay, so I could do as factor degree, which all I'm telling R to do is create a new variable called degree. If we already have one, just overwrite it. And how should I create it? Take the variable called degree right now and make it a factor variable. So I run it. And if I go into clean and look, nothing has changed here, right? They're just 0s and 23s. And if I do skim clean again, give it a few seconds, it should stop treating degree as a numeric variable and start treating it as a grouping thing. Yeah, there we go. So see, now it's counting this up, saying now you have a factor variable and you have 24 numeric variables. Okay. And now the summaries that it's going to give you is different. So it's going to say degree is a factor variable. No missings, 100% complete. There's no ordering to this. And there are 38 unique groups. 38 groups here. And it will also tell you which is most common. So 0 is most common, which is no degree. 62 is the next most common. So if I go into my coding system, it says the most common major in this data set is business. So, and this will be helpful when I want to do things like create graphs or use this variable somehow in a regression. I'm telling R, look, this is not a continuous or a count variable, so don't treat it that way. Even if I use it in a regression, don't treat it that way. Okay, so we can always recode the variable types, and that may help you in many cases where you want to use like a numeric variable, but you want to use it as a group thing, and you want to tell R, don't treat it as continuous or a count. It's really just a coding system. Okay. Now, suppose you look in your data and there are individual values that you're like, yeah, I mean, I get why that's the value, but I want to fix this. So for example, if I go in clean, we already learned that there are people in my data who are somehow 0. 0 for age. Now I might wonder why that is. One good thing to do is check your code book. So age is the person's age in years as of their last birthday. Is there any universe issues here? Nope. So literally just, I guess, 0-year-olds have survey responses somehow. All right. I might, just for a sanity check, take my data, clean, x equals age. Just look at the density of it. What are we looking at here? Okay. Neat. So that's fine. Nothing weird is happening here. There's a little weird spike at 97. I think that's because there might be... If you're older than 97, they only let you say 97, it looks like. So that could be why. But otherwise, everything else is good here. Even 1-year-olds do fill in surveys. Now suppose I thought there was something I wanted to change about one of these variables. Let's do it this way. Instead of age, let's say I don't want to ever make the mistake of thinking that degree 0 is an actual degree. So maybe I want to make them missings. Okay. So I'm going to keep going in my mutate. If you did a pipe and then did another mutate, that would be absolutely fine. Actually, you know what? I'm going to do that because I want to keep my comment for change the variable types. I want to keep it with this as factor. So let's do another mutate. That's fine. Now I want to take degree, and now I want to turn the zeros into missings, just so I know that this is never a actual degree. Okay. So what I might do is use what is going to be a very helpful function called if-else. So if-else, here's how it works. You can see that after I type if-else, it's saying you need a test, a yes, and a no. That's what needs to go inside these parentheses. So the test is saying, R, check if this is true. So I'm going to say if degree equals 0. 2 equals is going to be your friend on this test. Is exactly equal to 0. So check and see if that's true. Okay. If it is, then I want this new variable degree, I want it to be missing, NA. Just take the 0. So check and see. If degree is 0, then this row should get an NA. And if degree is not 0, then just leave that value alone. Okay, let's run it. There we look. Maybe close it and update it. No, sometimes it doesn't want to. There we go. Update right away. Now all the zeros got flipped to NAs, so these people are missing a degree, and this one person has one, and it's in 10, whatever that was, category 10. Okay. So we can always change individual values within your data by using if-else. If it's this value, then flip it to this one instead, otherwise leave it alone. Okay. So recoding individual values, we did it. Recode individual, spelling is hard, values. Okay. Now, suppose that my research was specific to people with a college degree. So for whatever reason, I don't want people in my data who don't have a degree. So the population I'm interested in is degree holders. Or let's say I only want people above the age of 18. Okay, so let's do it that way. Let's do age. Suppose I only want people to be in my data if they're over the age of 18. Okay, so what we can do is we can take our data here and use what is a filter. A filter is telling R, okay, only keep the rows where this is true. So it's like keep. Only keep the rows where this is true. If it's not true, I don't want them. Get rid of it. So if I say age is greater than 17 or greater than equal to 18, what I'm telling R to do is check each row. Is this person over 18? Keep them. If yes, if no, they're out. Let's run it. All right, now we can look in here for a sanity check and just look at some of these ages. Do we have anybody over 18 or below 18? We should not. Although a quicker way is just rerun this density plot, and you can see now nobody in the data is below 18. And you can see how many we lost. We've got 2.7 million now. We had 3.3, so we lost 0.6 million observations from the data. So filter is your friend for removing rows from the data. Let me add another filter, because what's going to happen very often for you probably is that you're going to want to remove rows where they're missing a crucial value. So like if I wanted to know what is the effect of distance from downtown Chicago for an Airbnb's price, and I pull this Airbnb data and a bunch of listings are missing the price, well then I'm just never going to be able to make use of them in any of my analysis. And also, if I did make a graph of, if I do a density of distance from downtown, I actually don't want that listing to be in there. I really only want to make graphs and tables and do anything with the listings that are going to end up in my regression. Okay, so we might want to just drop the missings. So the way I would do that is if you add a comma, you can add a second thing to check for. Just filter, I want to keep age greater than 18, and I want to also keep based on this next thing. And whenever you put a comma, it's a good idea, or you add an additional argument here, it's a good idea, press enter, make your code easy to follow along with for yourself. So now I want to remove the missings. So let's do it for degree. Let's say I want to remove the people who are missing a college degree. But filter is keep, it's not remove. So I need to tell R that I want to keep the ones who have a value. All right. So what I could do here, well, let me give you before we get there, let me show you how something else works. If we go back to this filter, let me play around with it. I could say equal to 18, age equals to 18. And this would keep only the 18-year-olds, 47,000 of them. Okay, so I can always do that. Exactly equal to this. Suppose I wanted to just get rid of 18-year-olds. This is weird for this exact research, but it might come in handy. Suppose I wanted to just get rid of 18-year-olds. So I wanted to keep all of the other ones. You could think of a very complicated way to code that, I guess, but the easiest is to say keep if age is not 18. An exclamation mark is your friend. It's like does not equal. You can kind of think of it as an equal with a slash through it. Doesn't equal 18. You can run that. Now it got rid of those 18-year-olds. So equals or does not equal is also good. Let's go back to our greater than or equal to 18. So now I want to keep the non-empties. Now, so you might be tempted to say degree does not equal NA. And I wish that worked. Unfortunately, now we have 0 data. So something happened here. Okay. Well, getting rid of missings is a little bit different. So instead we need a function. It's called is.na. And what this does is it just checks. It's like a little check to see, is this value missing? So if I do degree here, what this is doing is it's checking to see, is degree missing? And so if I do is degree equals to is NA, is it missing? And I want to keep it if that's false. Because is NA spits out trues and falses. So check and see if degree is missing NA. If it's true, I want to keep it. Or if it's true, I want to get rid of it. If it's false, I want to keep it. And filter is about keeping. So keep if they're over 18 and the missingness of degree is false. Therefore, it's not missing. Let's try it. Equals, probably we need 2 equals. Aha. Now, when I find my degree variable, there are no missings, just all degree codes. So that this is NA, plug in your variable, equals false, will tell R, if you do this within the filter function, it's telling R, keep only the rows that are not missing any values for this variable. A word of warning. You don't want to remove any rows until you have to. So I wouldn't suggest going through and doing this for every single variable in your data set. So for example, suppose I have missings for the class of worker that they are. What this means is something like unemployed, private sector, public sector, or they own their own business, I think. Suppose that I have missings here. I don't necessarily want to start deleting all the rows if they're missing class worker until I know it's going to be an important variable in my data, okay? Because we want to keep as many rows as we can. So only in basically as a last resort do we want to start deleting rows, or we would do it to sharpen the sample to the population of interest, okay? But otherwise we want to keep as many as we can. Removing rows from the data, boom, we did it. Filter. Filter is your friend. Put inside of the filter command all the arguments or all of the conditions you want to use to form your sample, to keep the observations you want. All right, next. For a lot of us, we are going to have, there's going to be these coding systems, right? So my degree is this system whereby I've got these 10s, 11s, 37s, 36s, 3s, and of course I could go back constantly. I could keep going back here and finding that, okay, well 13 is environment and natural resources, 37 is math and stats, but there will be a simpler way to do this where I can get these values into R. So in any code book you have, what you could do is go in here, copy this, paste it in Excel, get rid of any nonsensical stuff like any of these weird little headers. I also don't need these X's. So within here, I now have, and these need to be in separate columns. Here should be the coding system. Here should be the label, the thing that I actually want to see, right? This is the actual field. I'm going to call it field. I'm going to make it lowercase because I know I want everything in lowercase anyways. And then I'm going to call this degree because that's what it's called in my actual data frame in R, okay? This needs to match the name of the coding variable in R. And I'm just going to save this within my, so I'm working within this project called cleaning, and so I'm just going to call this degree codes. All right. So this is going to be the way in which you can get these labels into R so that you can look directly at them, okay? And then what we need to do now is come back up. I like to put all of my data entry up here at the top, so let's call these codes, read CSV, degree codes, and open it, and run it. Now I've got it in here, right? So it's saying, okay, zeros are NAs, 13 is environment and natural resources, 32 is our law degrees, etc., etc. Okay. But now this is not yet what I want because I don't want to constantly go into these codes. I want it to literally add a column in my clean data frame with this field listed and just put it right in there. Not as hard as you might think. And this is where coding is going to help because in R, or in Excel, this would be a royal pain. So all we need is this, keep that there, command called left join. Left join. So left join says, you can kind of visualize this. I've got clean data. Think of it as being on the left. Let's move to the left. All right. And now I've got these codes on the right. And what I want R to do is find anybody with a degree 11. So go through here. Find all the 11s. Here's one. And tack on the far right side, a variable called field. And it should say agriculture for person 11. Or this first row, it should say degree 10. So the first thing that pops up should be a 10, which I don't even see in my coding system, which is interesting. Did I make a mistake? Interesting. Okay, I just don't have a code for that. We'll cross that bridge when we get there. Degree 10. I don't know. That's all right, though. Let's keep going. Left join. Here's how it works. First, you tell R, okay, I want to join in the codes data. And I want you to connect. So take this data on the left, clean, and connect in the codes based on the variable called degree. And we put that in quotes or single quotes. Double quotes, single quotes, doesn't matter. Let's see if it works. Clean. All right. So those 10s, because there's no 10 in my code listings, that it just leaves it as empty because it says we didn't find anything in codes for 10, which makes sense. If I still had NAs, if I hadn't dropped my NAs here, if I still had NAs for degree, they would also get missings for field. But otherwise it's working. Just a little sanity check. You might say, okay, 37s, they got math and statistics, and indeed 37 is math. Oh, looks like it's working. Okay. And now this is cool because now that I have these codes actually in here, if I want to count a categorical variable, right? Count them up. I would typically do this, count degree. Right? And then sure enough, it does, it counts, says, okay, well there are 1066 with degree 2, 7, all the way to 10, whatever. Counts them up. 37s, there's 178,000 of them. but I don't know what 37 is when I do that. However, if I count field, voila, much better. Now the count is actually spitting out the fields that these people are in. So it tells me that I've got just 1,500 law students in here. Okay. Now something's going on. I don't know why. I'm getting no business students. So this is where, if I was not in the middle of a video, I would now go back and figure out, okay, what's happening here? Why is this coding system not matching? Why do people have 10s? And then I have no code for that. But honestly, at the moment, I'm stumped. There's probably a good reason. But this is how we do it. Left join will give you your variable labels. It will also help you merge two data sets together, which may be of interest to many of us as well. But we did it. Merging in labels. Labels for a categorical variable. Cool. Next. A lot of categorical variables only have two categories. Like, if we go in here, my sex variable, 1s and 2s. That's all they're in here. Let me check and make sure, but clean count sex. 1s and 2s, that's it. And I would want to make sure I know what those codes mean. Okay, 2 is female, 1 is male. Well, then we might as well just create a dummy for this. So I might want to say mutate again, and I might call this dummy female. And remember that we named dummy variables. A 1 should mean this thing is true, and 0 is it's not. So if else is your friend here. So maybe I'll give you a second to think. What would we put in here as a test? And what goes in yes and no if we look at this sex variable and 2 is female, 1 is male. So the first thing that needs to go into the if else is check. Check and see if this is true. Like, check and see if our sex variable is exactly equal to 2. If it is, then this female variable should have a 1, and if it's not, it should have a 0. Let's try it out. And then for a sanity check, it goes 2, 1, 2. When we scroll over to the right, female goes 1, 0, 1. Great. Now we have a dummy variable for, is this person a female? Okay. So that's helpful for categorical variables. When there's just two categories, you might as well create a dummy. Or suppose you want, I don't know, you want to know if this person is a senior citizen. I don't even know what qualifies as a senior citizen. How old do you have to be? 62 or older. Okay. So suppose I wanted to create a variable called this person is a senior. I could put a comma after I'm done creating my female variable and call this senior. And this should be a dummy as well. If else age greater than equal to 62, then yes, they're a senior. Give it a 1. If not, a 0. Not a senior. Run it. Sanity check. First person is a senior. Second person is not. 1, 0. Great. And then if I wanted to count up my senior citizens, how many have I got here? 281,000. 635,000 are not. So create new variables like dummies. Great. Done. If else. If else is your friend. Okay, so missing value, creating new variables. Missing values we already took care of too. We said how do we find them? Skim. Skim will find your missings, your NAs, and then how do you get rid of them if they're in your important variables is NA. So removing rows from the data like missings. Boom. We did that too. All right. Now, Eventually, your project is going to have a main question. How does this affect this? And it's going to require you to use all of your data all at once, okay? However, you might at times want to just analyze subgroups of your data, right? So subsets. So maybe like what I want is to analyze my X and Y variable, their relationship just for senior citizens. Okay. Now I could always put like a filter. So like for example, if I want to run a regression, I could always do something like this. I can always do clean, filter senior is 1, and then run my regression, right? Or if I knew I was going to have to use just senior citizens for a lot of things, I could just subset my data. I could say, okay, take clean and keep just the seniors and save the filtered data, the filtered down to senior citizen data, save it back to the data frame called seniors, and then I can just work with just senior citizens as its own data frame whenever I want, and I can refer to it. So now I could do, okay, what is the density of ages, but just for seniors, right? And then R is picky about every little letter, seniors. And there it is. There's the density of age for senior citizens in the data. Okay. So subsetting data, we've done it. And R is cool because it will keep track of all of your data subsets over here, so you can refer to them at any one time, which is kind of nice. Finally, some of us might want to aggregate data. This could be useful for summary statistic purposes, or maybe aggregate data is actually an object of interest in your research. So like suppose, for example, I want to know if people are employed in a high-paying, if college students are employed and they have a high-earning major, like, do they work more? Say, I don't know. If I have a college major in which everybody in this major generally makes a lot of money, do I work more? So it's not about my own money, it's about the money of the people in my major, okay? So what I would want to do is, for example, take clean, group by, and then you add a factor variable in here, mine is degree. So group together all of the rows in which the degree is the same, and then summarize the mean salary equals mean of, let's remember what my ink wage is, what it's called. I would probably rename that if I was going to keep going here. Let's just do it. I can always go back and add more. Let's call it salary equals ink wage. Rerun this. All right. So mean, this should be salary now because I renamed it. Run it. This will give me mean salaries for every possible degree. Oh, there's a reason, right, that I brought in these labels. Let's use those. They're called field. There it is. Let's group by field. And then find the mean salaries. All right. Although, careful. This is why we use skim and want to investigate our data. A lot of people have a salary of 0. What does that mean? If I go back in to my actual data system here it is, wage and salary income. Let's figure out what's happening. This reports pre-tax wage and salary income previous year. Amounts in current dollars are not inflation adjusted. Codes. 7-digit numeric. Ooh. 999. If you're $1 short of $1 million, that means it's missing. If you're $2 short of $1 million, that means it's also missing. Also, only people age 16 and up report this. So the zeros probably don't make sense either. The zeros probably mean they don't have a job. So what I would want to do is carefully figure out why ink wage could be 0, why salary could be, it's called salary. Now why could salary be 0? What I'll notice is the usual hours of work, the weeks that they work, these are also zeros. They don't have an occupation or an industry classification. The class worker is 0. And so, yeah, I would carefully go back and make sure, but it sure looks like all the zeros for salary just don't have a job. So maybe, before I do this, what I'll say is filter. It's not ink wage anymore, it's called salary. Salary is positive. And then do it. All right, so now this says, here's the average salary of the people who have a job. And this was their major in college. Okay, so that's good. The other thing that's happening is, remember, we saw 9999s. These are missing, and so are 9998s. So I might do salary does not equal 1, 2, 3, 4, 6. And salary does not equal 8. Because those are very misleading. The person does not make $1 short of $1 million. Okay. So here's what I find. And again, I think something's going on in my coding system because I'm having a hard time believing that my communication students are making the highest salaries. But that's another problem. Anyways, suppose I wanted to keep this. All I need to do is save this back to summed, whatever you want to call it, doesn't matter. Now run it. Now I've got all of this data here on means, salaries by majors. So if you wanted to work with aggregate data, you can aggregate it yourself and save it back to a new data frame. Now if I wanted, I could then left join this back into my clean one, and then it would say, well, the people in your major tend to make this much. And it would say that for every individual person in my data. We know how to do that. It would be a left join, and then I would put summed, and then I would put by field, and I would have it. All right. Aggregating data. We did it. So best practices for data cleaning in general, use something like Skim to just get a glance at what is happening in your variables, how many are missing, what values are common, what are the distinct values, what's going on here, and then go from there. Happy cleaning.